one of the secrets to physics, this is the sad thing, people get all worried about the math. Nobody checked really in their concerns reading. One or two people kind of got close to that. Reading is the #1 problem and the #1 reason people fail physics, is they just can't read. That's just what it turns out to be. You have to read these stupid problems I write, because I write in a weird, complicated way. And you've got to be able to read the problem and figure out what I want. Now let me ask you, how many of you still have hopes of going to some sort of medical profession broadly defined? It could be dental, could be orthopedic, physical therapy, right? Yeah, oh, you're such a hopeful group, yes. Pharmacy, right? What do you have to deal with? You deal with people who come in and say, the other day I was driving my car and then my dog barked and my elbow hurt, but then I was sitting this way and it was actually my eye, but then I think it was my finger, and then I sat down, but then I stood up, and then I was jumping, and the sky was blue. What's wrong with me? Right? And so out of all of this information, you got to figure out what is actually wrong with them. That is why I write really confusing problems. Right? So you can practice being a medical person and reading really confusing statements and figuring out what's going on. Now, it's not quite that bad. I'm not as bad as the average patient. But you do have to, in life, learn to extract information. Whatever profession you end up in, even if it's not medical. You have to recognize in a situation what is the actual key information that's going to make me successful here. Some of you have wrote in your what you would like to get out of this is something that would actually apply to the real world. You may or may not use the physics we learn again. You actually may, some of it. But what you will learn and what you will use is an ability to read and recognize in a situation what matters. And that is an absolute critical skill. There's nothing that doesn't need that. So that's #1, read the rules carefully. The other thing is, if we go, there. If we go down to some of the comments on the pre-quiz where I asked, what's the greatest fear? These are actually some direct quotes, but let me tell you, there's 300 of you and you all almost said the same thing. Surprising, actually, #1, this is the first time I've seen this a lot. And it just goes to show you can do something for 16 years and still something new can happen. There are a lot of you who actually admitted to never having a physics class before. You're in luck, because you were not previously confused by a high school teacher. Good. So, that's actually really mean of me. Both my mom and sister teach high school, and now my wife does too, so I really should not say anything negative about high school teachers. Memorizing all the formulas. I'm so nice. You have to do that, yes, but it's only 2 sides of a page, and I give it to you at the beginning. If you go to the web page, I gave you all the formulas you need to succeed in this class. They're on the website, they're there. You can go memorize them tonight before anything else happens. Done. Good. Okay. I think it would be the math part. I like the confidence in what was going on here, because a lot of people just wrote math, and that was it. Yes, I will admit, how many of you last took calculus over a year ago? And that, I presume, was your last math class? Yeah. That is the tough part in this class. The math is the tough part. And I try to minimize that for that reason, but also give you enough chance to practice it. The goal on the tests really is to minimize the amount of calculations and math you have to do so that time is not a problem. I do try to do that. So I'll just tell you, we don't always succeed, but you want to practice your math. You've got to be refreshing yourself on it. We will use calculus in the course. I have no problem in lecture using derivatives and integrals. I tell the TAs to tell you, and I'll let you know. Very rarely, I don't think I've ever given a test problem where you have to do an integral. It might be on the homework. It might be in discussion. But one of the reasons I use it a lot, every professor has their own philosophy, and it's very, very hard to do E&M the next quarter, 3B, without doing integrals. I don't really use them here on the exams because I want to give you a chance to remind yourselves how to do that and get caught up. So we'll use them in class and stuff. But practice them. Even though they won't be on our test, you'll need them in the next class. So you might as well start practicing it now. So that's, for Physics 3A, if you get really good at your trig, and that's why I asked that as one of the quiz questions, how do you feel about trig? Trig is the most important thing. You cannot do mechanics without being comfortable with sines and cosines and tangents. It just won't happen. And so if you're not comfortable with it, either seek me out, seek the TAs, go to office hours. Speaking of which, I forgot to announce, office hours will be Friday. I'm not sure which room yet, so you will get an email with that. Not understanding the concepts. This is one I've thought a lot about. Physics can be difficult this way. One of the things what makes it weird in physics is you have to just kind of split yourself into two. Accept what I tell you is true even if it makes no sense. And use it with confidence even if you don't understand it. And then eventually you will see and understand. You can actually, I shouldn't admit this out loud on camera, you can actually be successful without understanding anything I say if you just believe me. That's not the best thing, because it's hard to believe something you don't understand, and you get nervous and you use it wrong. But in a sheer act of desperation, if you just say, I have no idea why, but Professor Dennin said this, I'm going to do it, it'll probably work. Okay? But reaching comprehension in physics really ends up being about doing a bunch of practice problems. And everybody has their own level at which it suddenly makes sense. It might make sense for you when you do 1. It might make sense for you when you do 3. It almost never makes sense just reading them in the book or watching me. Until you actually do, it is the rare person who will understand my lecture right from the beginning. All of it. Except this part here where I'm just like waving my hands and chatting. Once we start doing physics, there will almost always be parts of lecture you don't understand, and you need to go home and struggle with, work through, do the problems. And next year you'll wake up one morning and you're like, oh, that's what he meant, I could have passed. So you want to keep that in mind, that really the understanding is a bit weird that way in a physics class. So what really happens? At the end of the day, this is about solving problems. And there's really 2 parts to that. There is getting the right answer. And there's explaining how you did it. And one way I could do the class is I could give you exams and say, the only thing that matters is getting the right answer, no partial credit. Boom. Go do that. The other thing I could do is say, the only thing that matters is your explanation and everything will be partial credit. What you'll find is, in fact, the exams are both. There's a bunch of questions where you just get credit for getting the right answer. We don't check your work. You either get it right, you get it wrong. And then there's always, on our exams, there's 1, and on the final, there's 2 questions where you have to explain your answer. And if your explanation isn't good, even if you get the right answer, you will not get full credit. That's just the way it works. And you can go on the web and find it. We have this cool 5-box solution. And the first thing you do when you meet a physics problem, I told you, is you have to read it and understand it. And then basically describe the key elements. So in this top box, and you'll see this as I solve problems in class, I will be talking and thinking in these terms, and then I will often post the solution in a nice, neat format that actually shows the final solution. But the first thing you'll do is tell me the situation. You'll make sure you know what's going on. Are things moving? Are things flying? Are things at rest? Are there forces? Are there no forces? And then the next thing you really have to decide is what it is the question's actually asking you. Can't tell you how many times a student reads a problem, does a whole bunch of work, and doesn't actually answer the question. Particularly if the question is, Evel Knievel tries to jump over 7 buses, does he make it? I often get an answer 10 meters. So this is like the easiest 2 points you'll ever get in your life. That's almost always worth 2 points, to just tell me what do you have to find. Because the nice thing is I make you write the answer here, and like the really good students check that they match, that the answer actually answers the question. Now, the other thing you have to be able to do is tell me what you did and why. And that's the part that we'll go over a lot, but that's the strategy. And the number 1 way to succeed in physics is never do anything unless you have a reason. It's as simple as that. Do not take the next step unless you have a reason for taking it. And I will tell you this, and I'll say it over and over in this class, I teach you very little. There is not actually a lot in this class. It fits on two sides of a piece of paper. So your reason for doing anything has to come from those two sides of a piece of paper. Worst case scenario, you start at the top of the paper, try that, no, it doesn't work. Then it doesn't work, then you just go until one works. But only use the things from the piece of paper and make sure you have a reason. And then I give you space to do the fun part that you all like. This is where you do the math. And then it's helpful, like I said, to check your answer. Does it make sense with the question? So you will see this a lot. You'll see it in discussion section. This is the only week we won't be doing this in discussion section, but you'll have one next week. And there'll be examples on the web and different things like that. Any questions on this? And I can even just show you real quickly while you think if you have a question. So if you go to the course website and you go to important class information, you will see the two things I talked about. Here is the required concept sheet. And the only reason it takes up 2 pages is I actually include a lot of words to explain what they are. It's actually less than that, if you think about the actual stuff you need to know. And then this is and this will actually show up on every exam. And that is how you'll do the problems. I recommend, we don't require it for the online homework, but I recommend occasionally practice some of the homework problems by using the boxes. It's just a good practice. I also strongly recommend, anytime you're doing physics in this class, have this sheet with you and just note, what did I use from here? What did I use from here? What did I use from here? And if you're trying to use something that's not on here, why am I doing that? You know, did Professor Dennin actually make a mistake? Probably not. It's possible, but probably not. So that's, like I said, today is about telling you how to be successful, since many of you put that as your goal. Any questions now at this point? Yes?
So in terms of the strategy, what if there's multiple ways to do a question? So if you do a longer method, would you dog down?
Not at all. The strategy is your strategy. I will tell you this. Occasionally students, we're not dumb, we were students too. Occasionally students will try to write down every concept in the course as their strategy. You will get doc points at that point, right? If you write down steps that you never even use and clearly are not related to the problem, you will lose points there. We do dock you for what I call the brain core dump, where you just write down everything. But no, and what's even cooler is if you pick a strategy that seems reasonable but doesn't actually work, you only lose the points for getting the problem wrong and maybe with the calculation, or if you do the calculation all right, matching that strategy, get full credit for the calculation, lose a point maybe in the strategy. So it's actually a good way to do partial credit. It really benefits you a lot. And no, we don't penalize you for doing it differently than we do. Which leads to my next point. This is the one warning. I don't really like textbooks. So I pay little attention to the textbook. The textbook might say it a little differently than me. This is not meant to confuse you. This is to go to the point. There often is not one way to do a physics problem. And I actually view this as a benefit to you. If the textbook and myself and the TAs all present slightly different ways to do it, then you can pick the one that makes the sense to you. I am not going to make sense to all 300 of you. But between myself, the TAs, and the textbook, one of us will. And then you'll be able to know how to do it. So if you see me do it a certain way and the TA does something different and that makes so much more sense, do it that way. You're not going to get marked wrong for it. That's the way to do it. If you actually were one of the people who had a good high school teacher and they taught you something different than what we did, it works, do it. Use it. Use what it works. And I already said this, lecture will not always make sense, but that's okay. It will eventually make sense. Keep in mind, notice what I do, and 5 of you will still complain about the end, but that's fine. I don't have nice, neat PowerPoint slides that I hand out. You don't get nice lecture notes from me. I will post, I'll save these, hopefully if it works, and try and post my notes. But as most students notice, I'm going to be scribbling all over them and drawing things and crossing stuff out and drawing funny lines. So don't rely on my notes as lecture notes. Rely on your own crossed out, scribbled, drawn on notes. So now the fun part. We get to practice our first clicker question. So get out your clickers. So the first thing you should do is make sure your clicker frequency is AA, which I believe is the default, I hope. Does someone have a clicker? Can I start at the back? Is yours working?
Yeah, it should be working.
Yeah, see if you get a nice green light. It looks like they're working because there's 120 of them. So that's good. You don't have to change the frequency. That works well. Make sure it's turned on. A lot of people have trouble with that. It's not on, and then they don't get an answer. Those are the big ones, particularly the later clicker questions in the class, because it sits around and then it goes off. The other thing is, I try to update. I will not update any of these to the end of the week, because it's just pointless until you all get registered. And then after the end of this week, I'll try to update it maybe twice next week, so everybody knows they're getting the clicker points they're supposed to get. You have to go register it. You have to link it to your ID. You can use, you could have borrowed a friend's who was linked to their, so you can use that. You can use your friend's. It can be linked to your ID. It can be linked to theirs. It can't be linked to two in the class. So if two of you are trying to get credit off the same clicker, only one of you will get credit. And actually, probably the worst thing is, since you need to do 80% of them, it'll probably accidentally split it 50-50, then neither of you will get credit. But other than that, it'll work. But if you are sharing someone's, that's a likely scenario where the automatic update doesn't catch you. Don't panic. I can find you and do it manually. So even if you're not registered, it saves all the clicks with that clicker, and we will make it work. So do not panic. Usually, I give you 30 seconds to a minute. Obviously, I've been talking while you're doing it. Hopefully, you all answered. Physics is a really hard subject that I have to take. My favorite subject. I have no idea what physics is. The study of the interaction of objects in the physical world. Yeah, and so we put up the answers. Oops. No, we put up the answers. And as always, two of you managed to answer an answer that wasn't there. I've never figured that out, but it happens. Most of you went with the study of the interactions of objects in the physical world, which is what we'll be doing. This is a case where the others are not really wrong. It is hard for some people. Some people do really like it, and some people have no idea what it is. So this is a case where all of these would work. At some level, this is the best answer. Now, one of the reasons I don't make you get these right or wrong, most of them will have a right answer. And this PowerPoint I will be posting after the lecture, which will have the question and then the answer correct in red. Some of them will be like this, where really there's not one right answer, but there's one that I'm trying to highlight or that I like. And again, that won't happen on the test that you'd get because there's no multiple choice on the test anyway. But that is something to be aware of. So hopefully everybody got theirs to work. That was the main thing we're doing there. Now, what are we actually going to be learning in this class? Well, as I said, everything is on that piece of paper, but you want to think of it as two sets of stuff. We're going to learn a bunch of definitions, and we're going to learn what I might call principles, rules, or laws. What's the fundamental difference between these two? One way to think about it is a definition something that you can, You can always use a definition. But it is not always useful. And that's something you have to keep in mind. So we'll see that a lot. Now, principles, rules, and laws are obviously the opposite of that. You cannot always use, you need a reason, and we'll see how that works. But they're generally the most useful when you pick the right one. And that's really the heart of problem solving in physics. It's asking yourself, which of these applies to the situation I'm doing? And when people say I'm having trouble with physics or I have trouble with the concepts, what they're really having trouble with are when to apply these. When do they work? When am I able to use them? Hopefully this you just memorize and accept. You have to. This you just have to accept, because that's what a definition is. We've just defined it that way. There's nothing really there to understand. We could have defined it a different way, but we chose not to. But the principles and the laws and those other things, they come fundamentally from experiments. And if you really want to ask the question, why is it true? It's true because experiments show it's true. And that's just kind of the first level of acceptance. We wouldn't be doing it if it didn't actually work. Now, this is where it really comes down to in that strategy part, right? Doing something for a reason. Why do you have those? So let's compare these two real briefly. And I'm going to give you a definition that we might see very soon. And the definition of velocity. Anyone remember from back in their youth when the few, like 5 of you who took physics, what velocity is? Meters per second is a good way to start, but if we want to be a little fancier and use calculus, displacement over time, better, but again, let's get real fancy and use our calculus. Yeah, but you're still not using my calculus. Integral of acceleration, way too complicated, but I like it. Correct. Derivative of position or distance or displacement with respect to time. So dx dt. And this is why I love math, because I don't have to write a lot of words I can't spell. Right? I just write my short symbol. Now, you can always use that to find velocity, except for one small problem. It's the definition, it always works, but you better have position as a function of time, or you can't take its derivative. That's just the way it happens, right? And in fact, that means you need it as a function of time. If I tell you my position now is 2 meters, what's my velocity? You better say I don't know. Because I don't have anything I can take a derivative of. I just have my one point. Now, in contrast, we have a concept that we'll learn about called kinetic energy. Now, this is kind of an interesting one. It is also a definition in its own way. It's 1/2 mv squared. It's a slightly different definition because it's a definition of kinetic energy, not of velocity. But it means if kinetic energy is a concept we're able to use, we can now use it to find velocity. It's one of our other ways of finding velocity. And another good way to approach this course is that sheet I gave you, again, are all the formulas and concepts you need. What is one of the most common questions we'll have? You look at the problems. We're going to ask you where something is, how is it moving, what's its velocity, is it accelerating or not? Pretty much, those are the only things you want to know about stuff. Where are they, how are they moving, and did they hit someone? And so you're going to want to keep track of all the different ways you could possibly find where something is, how is it moving, velocity, and its acceleration. And already we have 2 of them. And that is how you'll approach it. Can I use the definition? Can I use some other concept? Any questions on that basic idea? We're about to practice it. So let's take another concept. Energy is, oh wait, sorry. Energy of a system is conserved if the work is 0. Notice, a very useful word to watch for is the word if. That tells us there's a condition here. We can only use this under a certain reason or situation. So let's go to clicker question number 2. If you're faced with a physics problem, now I know I wrote the definition real fast and I removed it, but you all memorized it, I know, in that 30 seconds. If I'm going to use conservation of energy to solve a problem, I must first know the system in question, the work done on the system, that the work on the system is 0, all of the above, only 2 of the above. I forgot to pay attention to the first question, how many people answered. I'll give you 5 more seconds. Oh, 1 more person wanted to answer. Exciting. Okay. Let's see what we got. Interesting. Only 2 of the above are needed is what a lot of people went for. What I want you to do, we'll do this a bunch in the class. About half of you think it's 2 of the above, half of you think it's something else. Odds are somebody next to you disagrees with you. Point out why they're an idiot. I mean, politely discuss why they might be wrong and you're correct. And once you're ready, vote again. Let's see if you convinced anybody of your view. You can talk for another second too if you want. Okay, let's answer it now. 10, 9, 8. I count slowly. 7, 6. Some of them go fast. I'm not a real regular clock. 5, 4, 3, 2, 1. I like how different numbers of people answer each time. It's exciting. It's like a game. Okay, the E's convinced a few people, so it increased a little. Let's see what I cleverly thought. Now, oh yeah, oh this is horrible. Aren't you glad there's no multiple choice on the test? I overheard a little bit what people are saying. Notice this is not really a logic puzzle. We're not taking logic and philosophy 3A. This is physics 3A. And you need to know the system. If you don't know the system, you don't know what you're doing. You need to know the work done or you can't determine if it's 0. And you need to know it's 0 or energy is not conserved. It really is all 3 go into it. I mean, yes, you might want to have a deep philosophical debate that C includes B, because if you know it's 0, you know the work. But the problem is, a lot of people when doing physics skip that step. They skip checking what the work is, and they think they know it's 0 without being really careful to think about what the work is. And that's why I actually separate the two. Because you have to be that kind of anal when you're doing physics and really check each step carefully. Now, we have one final clicker question, which I will start. So I forgot to bring my tennis ball with me today, so I'll just kill the microphone. So I'll throw up my pen. I throw up my pen. At the top is the acceleration of the pen or ball at the top just before it comes down. Non-zero and up, non-zero and down, 0, or you don't have enough information. As you vote, you can actually ask your neighbor if you want. We'll do 10 more seconds. Five more seconds. And did those last 5 people want to go to get to 219? Didn't we hit 219 once, I think? Well, sorry, I'm going to hit stop now. You lose. Okay. 71% of you are wrong. Yay! I do this at the beginning of every class. Well, actually not the beginning of every class, at the beginning of the course. For one very important reason. Your intuition will sometimes kill you in this class. Whether you believe it or not, the acceleration of an object at the top of the throw is still the acceleration due to gravity. And it is non-zero and is down. By definition, we will learn acceleration means you have a change in velocity. The velocity at the top of the throw does become 0. It stops at the top. If its acceleration is also 0, meaning its velocity cannot change, what would it do? It would just float up there. Because its velocity would be 0 and its acceleration would be 0. This is one of those things where you have to take the definitions as I give them to you in this course incredibly seriously. We use them in a very, very particular way. And if you go with your gut instinct, you will be wrong. Now, that being said, there are a lot of things where your gut instinct is correct. You happen to live in the real world, most of you, and physics describes the real world. So it does work, but you have to be very careful to match your experience with the words we use. So Wednesday we get real serious. Take that pre-quiz before Wednesday, read the book, and we'll see you Wednesday.